Good morning, good afternoon, or good evening. Wherever you are in the world, welcome and thank you for joining us. We are live at AutoSens Detroit 2023. This is AutoVision News live at AutoSens. We are set up in the heart of the Motor City at the Huntington Place in downtown Detroit. My name is Carl Anthony, and with us today is Ewan Laidlaw, a mechanical engineer at TTP. He graduated from the University of Cambridge with a specialization in finite element simulation and complex system design. We welcome Ewan to AutoVision News live from AutoSens Detroit 2023. Good morning, Ewan, and welcome.
Good morning. Thanks, Carl.
So tell us, finite element simulation and complex system design.
Sure.
What is that? Give us an overview of what that is.
Sure. So finite element simulation is a way of mathematically modeling physics.
Sure.
So one example of a finite element simulation that I would do would be looking at a laser design.
Okay.
They have support structures. So being a mechanical engineer, I kind of interact with the optical physicists, but then I work out what are the stresses. And in order to work out the stresses, you do a computer simulation, which uses these kind of finite elements to do that.
Sure.
And complex system design could cover quite a range of things.
Sure.
So being a consultant, I work on quite a lot.
Right.
But I typically tend to mean it in the sense of there could be quite a coupled physics in a system. So maybe there's a stress in a body. Maybe that stress is caused by a vibration. Maybe that vibration is impacted by heat transfer. So you have all of these different areas of physics and trying to couple them together.
Was that always your passion when you were growing up? When did you develop a passion for this kind of engineering?
Yeah, it's an interesting question. So when I was younger, I was really interested in nuclear fusion.
Okay.
That was kind of what got me into engineering.
Sure.
And then during university, I did quite a few projects using finite elements for quite non-practical methods.
Sure.
So things that are very much going to stay in a lab for 20 years.
Right.
And right about the time I was moving into the workplace and finding my feet there, I found that it was actually more valuable for actual practical applications like the kind you find in autonomous vehicles.
Right. Which leads us to the work you're doing today. So tell us a little bit about TTP. Give us an overview there.
Sure. So TTP is a technology consultancy business. We're based in Cambridge in the UK.
Sure.
About 80% of our business is working for clients. So multinationals, startups, the whole kind of spectrum.
Sure.
We are employed to solve particular challenges, or we can also go from a blank sheet of paper to a design through to commercialization.
Sure.
And typically at that point, for example, transferring to manufacture, we then hand over to the client or their partner.
Right. With autonomous technology, it's really easy to look at automotive. I mean, we are here in Detroit, the heart of the Motor City.
Of course.
But there are other technology. Ewan, what are your thoughts there? What are some other industries where we can apply this technology, or what are some other industries that are already leveraging this technology?
I think it's a great point. I think, like you said, Detroit, heart of automotive, is very easy to think about it. But you could look to China, for example.
Sure.
They have autonomous vehicles pushing forwards. There's an interesting debate there, but thinking further out, like you said, drones. So in the drone space, the regulation is actually harder than automotive.
Okay.
They're having to fly at high speeds and away from anywhere where someone could actually intervene. So
Sure.
They're very much having to think about, say we leverage AI in order to make the drones autonomous. How do you, in a really tight regulated space like aerospace, how do you ensure that the AI is going to fail safe?
Right.
And there's some areas like autonomous farming where John Deere's been doing stuff for like 10 years.
Right.
But it's now starting to gain a lot of traction with like specialized robots, like kind of moving away from tractors.
Sure. Sensor fusion, whether in an automotive context, a drone context, agricultural context, sensor fusion is an important topic. You hear it a lot at AutoSens. What are your thoughts on sensor fusion? What's your perspective there?
Yeah, I think like you said, there's been a lot of people mentioning it in talks. So I was at AutoSens Detroit last year, and I think comparing last year to this year, there's even more focus on sensor fusion.
Sure.
So yeah, real hot topic. From my perspective, it's about redundancy.
Okay.
And I think it's fair to say people haven't worked out the best method of doing sensor fusion for that,
Sure.
which I think is why everyone's talking about it.
Sure.
Some people are trying to talk about it to get their sensors built in to sensor fusion, to make, for example, to make LiDAR key. That's
right.
Other people are talking about it from the kind of OEM perspective, and their view is very much, we'll take whatever sensor works, but again, they feels like they don't necessarily know exactly which one.
Right. Another topic we're seeing emerge here is this idea of materials to protect the sensors from heat, from vibration. As a mechanical engineer, what are your thoughts on materials? What is the relationship between materials and ADAS? What's your perspective as an engineer?
Yeah, so in terms of protecting sensors, are you talking about kind of like covers?
Yes.
Kind of heat management, for example?
Oh, yeah, that's an emerging topic here.
It really is. So I think LiDAR will be the biggest place where that's probably going to be needed first. So the power they use still,
right,
particularly for the long range ones, is still high.
Sure.
And I know I've spoken to like Formula student teams who use LiDAR, so like autonomous kind of hobbyists almost.
Sure.
And they were saying some LiDARs were unusable because if they didn't have the correct airflow, the correct materials to dissipate that heat, it would get too hot to touch. And being a student team, they just couldn't handle that.
Yeah.
Because it's kind of all lashed up.
Trends and developments, which is kind of what we've been talking about. But with trends and developments, from your perspective at TTP, your perspective as a mechanical engineer, what might be on the horizon that we should be paying attention to or maybe should be aware of?
So I think looking at automotive, I think there's still been a lot of people talking in this conference on the levels of autonomy.
Yes.
From chip makers talking about, is there a level 0.5?
Right.
In which case that's kind of how the OEMs interact with their tier ones.
Sure.
That's very commercial, but underlying that, there's all these kind of technical reasons for doing that. They're scared of being kind of designed out, and so they're trying to develop things which I think things like neuromorphic processing.
Sure.
So how you design better AI chips to go in autonomous vehicles.
Right.
Trying to stake a claim and get really tied in with an OEM early to be this kind of level 0.5, tier 0.5.
Yeah.
I think that could be really interesting in the future.
Ewan, great to have you on. And first time I've interviewed you, first time you've been here with us at AutoVision News. Fantastic perspective. From all of us here at the team, want to wish you a great rest of the show. Safe travels going back home. Let's do this again sometime. Thank you.
Thank you, Carl.
More to come on our AutoVision News LinkedIn page from AutoSens Detroit. From the Huntington Place, downtown in the Motor City, I'm Carl Anthony, AutoVision News.